So, here we go. We're going to start off with problem number 1. It's going to be kind of an introduction into completing the square. So what we're going to do, we're not going to solve this problem by factoring. We're going to solve this kind of as an introduction to completing the square. So we're not going to make this equal 0. We can see that if you were to look at the left side, you can see that this problem is kind of factorable because we can think of two numbers that multiply to 49 that add to 14. What are the two numbers that multiply to 49 but add to 14? 7 and 7. So if we look at this, if we were to factor the left side, two numbers that multiply to 49 that add to 14 are 7 and 7. So this would be x plus 7 and x plus 7. And since those are both the same, we would say that that is x plus 7 squared equals 4. So they are asking us to solve this by using the square root method. Solve this by taking square roots. Okay? So what we're going to do is we're going to undo steps to try to get the x alone. So we're going to kind of walk through those things. We're going to say, is there something we could add or subtract to the other side to get x alone? Well, there's a 7, but right now it's protected by the parentheses, which means we can't subtract it. So next step, is there something that we could multiply or divide? Nope, there's nothing we could multiply or divide away from the x. Third step, is there something, an exponent we could introduce or an exponent we could get rid of? Yes. What is it? The squared. And how could we get rid of it? Square root. And when we square root, how do we avoid killing a little horsey? Plus or minus. So we're going to say x plus 7. At this point, I don't really need the parentheses, but I'm going to put them anyway. X plus 7, and then what do I get on the right side? Plus or minus 2, because I'm not killing a horsey. All right, fourth step is me getting inside the parentheses. So when I get inside the parentheses, I start the process over again. I go back to the very beginning. So when I go back to the very beginning, I say, okay, now, is there something I could add or subtract to the other side to get the x closer to being alone? Yes, what could I do? Subtract the 7. So I'm going to subtract the 7 over. I have a plus or minus 2 that I have subtracted the 7 from. I have a plus or minus 2 that I've subtracted the 7 from. So I'm going to say x equals plus or minus 2 that I'm subtracting 7 from. So if I have a positive 2 that I'm subtracting 7 from, what do I get? Okay. If I have a negative 2 that I'm subtracting 7 from, what do I get? Okay. So my answers are -5 and -9. Any questions on how that works? So when you take a problem where you've completed the square, this is eventually what our problems are going to look like when we actually solve them. They're going to look like this. When you take a problem when you've completed the square, you actually solve that problem by taking square roots. That's the method that you use to solve it. Okay? So let's go ahead and solve number 2 as well using the same method. So we're going to leave the 20 there. We're just going to factor the left side real quick. We're looking for two numbers that multiply to 9 but add to -6. -3, -3. So we're going to say x minus 3, x minus 3. That is x minus 3 squared equals 20. So we got the same thing twice. X minus 3 squared equals 20. Okay. All right, so now we're going to walk through the steps. Is there anything I can add or subtract over? Nope. Is there anything I can multiply or divide over? Nope. Is there an exponent I could introduce or get rid of? Yep. What do I do? Square root. Okay, so I've got x minus 3 equals, and then how do I make sure I don't kill a little baby horsey? Plus or minus square root 20, okay? And now fourth step is where I can get inside the parentheses, and as I get inside those parentheses, I go back through these steps again. So what do? Add the 3. So I have x equals plus or minus square root of 20 with a plus 3 on the end. Now this is my exact answer. Plus or minus 20, square root 20 with a plus 3 on the end. That's my exact answer. My approximate answer is what I get when I plug that into a calculator. So square root 20 plus 3, negative square root 20 plus 3. There are my approximate answers with my decimals. So exact answer right here. And then approximate answers. I think this is probably the one step that makes it different from last year. Is that accurate? So we can make it a little bit more advanced since we are now 1 year older. You don't remember it?
I just know she and Gina so they all look the same. You know what I mean? The fancy sign thing, fancy fonts.
Sure. So every time you see a Gina worksheet, you're like, we did this! Okay, maybe we didn't do this. Okay.
I know we definitely did the quadratic
one. Okay.
But
this one maybe not?
Well, she gave us packets that were like this thick.
Sure.
And they were like just pictures or just sheets of Gina rolls. It was like lesson 1, homework 1.
Yeah, okay, so we don't know if we did this one yet. So, you think we did?
Yeah, we haven't gotten this.
Sure, okay. Oh, that's a good point. I forgot to simplify the square root 20. Let's do that. Okay, so off to the side, square root 20, let's simplify this. Square root 20. No, so here's the difference. In Math 3, they don't worry about simplifying radicals, and I've been teaching Math 3 for a long time. But you can't go through high school and never learn how to simplify radicals because it's a skill that you need to have, just in case at some point they ask you to simplify them. And I've taught Math 3 for a while. Like, I've taught Math 3 for 8-9 years now, where they've just been like, we don't simplify radicals anymore. It's a skill that I have. I know how to do it. And students, when they get to me, they've done it before. But we just don't do it in Math 3. We just don't worry about it. I forget that Math 2 is the year that you actually do it. And since this is my first time teaching Math 2, I'm like, oh yeah, this is the year that I have to make my students do it. I just forget. All right, square root 20, how should we simplify that? Do you guys want to do the tree method, or do you want to look for the perfect square? Perfect square? Dang, you guys are really not enjoying my trees. I always like looking for the tree, and you guys are like, I don't want to look for that tree. You like the tree? You do the tree?
I like it when you...
Oh, you like it when you don't have to do it, when I do it. I see. It's quicker if I just do the problem for you, is what you're saying. I know, I like the tree better. I'm a bigger fan of the tree. Okay. So it's 2 square root 5. Okay, so we would have been like, just kidding, not square root 20 plus 3. We would have been like 2 square root 5. You get the same answer, yeah. This is just the year in math that we actually simplify these. This is the year that we develop that skill, and then you get into Math 3, and we go, haha, just kidding, never simplify because we don't care. And you go, what? Did you lie to me? Yes, Nate. You add it because it was minus, and so we add it over. You cannot put it in there because the 2 is a coefficient, and those are not like terms. So the only way you could put them together is if the 3 was like a 3 square root 5. Then you could say I have 2 square roots of 5 and 3 square roots of 5, and that adds together to be 5 square roots of 5. You can't put them together unless they're like terms. Yeah, good question. All right, are we ready to move on to actually completing the square? Okay, so now we have to do the process, because if you look at this, What we have is not a problem that is set up to be exactly what we had before. So what we had before was something that could be factored. 49 was a perfect square. So when you looked at 49, it was 7 times 7. And when you looked at 14, it was like, oh, 7 times 7, 7 plus 7 is 14. It was set up perfectly to do exactly what we needed to do, which was x plus 7 squared. So that problem was set up to do exactly what we wanted. Here, it was -3 times -3 is 9. -3 plus -3 is -6. It was set up to do exactly what we wanted to do. These problems here, 56 is not a perfect square. So this one is not set up to do what we want it to do. So the first thing we're going to do is we're going to take this number, which is not a perfect square, not doing what we want it to do, and we're going to move it over to the other side of the equal sign. So I'm going to say minus 56. Minus 56, and then I'm going to say x squared minus 18x, and I'm going to put plus, and I'm going to leave a blank space so that I can put the perfect number that I want in that blank space. I'm going to put the perfect number that I want in the blank space, okay? And for the next part we're going to do, I'm going to use colors because, I don't know, I like to. So if you have a colored pen, I'm going to give you a moment to get it out. It's going to be helpful. Oh, I'm so sorry. Okay. All right, now let's think of this. Let's think of this the same way we did those previous problems. So the previous problems, we had the perfect square 49, and then we had 14, right? So we had two numbers that multiplied to 49, or we had two numbers that multiplied to 9, and added to 14 or added to -6. So right now we don't know what the perfect square is, but we do know that the two numbers are going to have to add to a -18. We know the two numbers are going to have to add to a -18. So can you tell what the two numbers are going to be? Yeah. -9. How do you know that they're -9? Yeah, you can split them in half, right? You know that half the numbers have to be on one side and half the numbers have to be on the other side. So -9 and -9. You know that the two numbers have to be the same. Does that make sense? Because the two factors have to be the same. Do we see how that works? The two factors have to be the same. Okay, so we're saying if we want this to work the same as the previous problem, then these two numbers have to be the same. So if they're both -9, then what number should we be multiplying to at the top? 81. Okay, so we're going to say, all right, the perfect square that I want is going to be 81. Well, I can't just put an 81 on the left side of the equation and say, oh, I added 81 to the left side of the equation, because now the equation is lopsided. The left side is 81 bigger than the right side. So if I added 81 to the left side, what should I do to the right side? I should add 81 over there as well. Okay. All right, so now that I added 81 to the left side and added 81 to the right side, I'm keeping my equations balanced. If I look at the left side, what factors do I have on the left side now? What factors do I have? Yeah, -9, -9. I have x minus 9, x minus 9. And how can I shorthand that? X minus 9 squared. Okay, now on the right side, I have -56 plus 81. That's 25? Okay, I believe you. All right, now at this point we have an equation to solve, right? So let's walk ourselves through the steps. First step, can we add or subtract anything? Well, no. Second step, can we multiply or divide anything? No. Okay, third step, is there an exponent we could introduce or get rid of? Yes. Okay. So x minus 9 equals what? Oh. Oh, okay, the poor horsey. was near the brink of death, but it was resurrected last minute. Thank goodness. Thank goodness. Okay. Fourth step, we're going to bust inside those parentheses and do what? Plus 9 over to the other side. Okay, so x equals plus or minus 5 with a plus 9. So we get two answers. We have a positive 5 plus 9, 14. We have a negative 5 plus 9, 4. Easy peasy, lemon squeezy. What a beautiful problem that was. All right. I don't know about this problem, but I am not liking this 2 in front. It makes it look different from the other ones. So I'm just going to divide this 2 over to the other side. Are you guys okay with that? Okay. So if we divide by 2 and divide by 2, then I get x squared minus 8x. Are we comfortable with that? Okay, and now I'm going to leave my blank spot just like I did over here. I'm going to leave my blank spot. And then I have a negative 30 divided by 2. What's negative 15? Okay. So now I'm going to think about what I need to do here. So I got negative 8 on the bottom. Okay. So what two numbers should it be? Negative 4, negative 4. So for it to add to negative 8, the two numbers it must have been was negative 4, negative 4. Okay. So what's the perfect square that it's multiplying to be? 16. Okay. So 16 is the number that fills in the blank. But now if I fill in the blank with a 16, my equation is lopsided. It's 16 bigger on the left side than it is on the right side. I got to add 16 on the right side to keep it balanced. Okay. So when I factor the left side, what do I have? X minus 4, x minus 4. And how can I shorthand that? X minus 4 squared. Okay, and what do I have on the right side? 1. Okay. All right. Add or subtract? Nope. Multiply or divide? Nope. Exponent? Yup. Okay. So I get x minus 4 equals what? Plus or minus, what's the square root of 1? Just 1. Okay. And then I can bust inside those parentheses and go back to the beginning. And what do? Add the 4. So x equals plus or minus 1 with a plus 4 on the end. So if we have a positive 1 plus 4, was that a yawn that was a yell?
Or maybe just a yell.
Okay. Negative 1 plus 4. Okay, okay. Well, these are kind of nice. Are these kind of nice?
I like these better than the other thing. They're all really they're not big.
Can I blow your guys' mind real quick?
Depends on what I don't think.
These work in every single problem, just like the quadratic formula. They work for every single problem the quadratic formula works for, these work for. Because this is where the quadratic formula comes from.
Yeah, very nice.
It's where the quadratic formula comes from, and here's what I'll tell you right now. If you were to take this problem, if you started this, I'll show you. If you started this problem and you said ax squared plus bx plus c equals 0, and you did the process of completing the square on it, you would come up with the quadratic formula. You would literally make the quadratic formula.
Wow.
To not complete the square.
Why?
Because some people don't like it. There are probably people, don't worry, there are probably people who didn't have me as a teacher, so they thought it was more difficult. That's probably why. They didn't have Miss Rice as a teacher back in the day, and so they were like, oh, this is so hard, how can I do it easily? And then somebody was like, oh, this is the quadratic formula, and they were like, oh, thank goodness, we'll do this instead. That's probably why. Okay, now, if you can sit down and use this process and come up with the quadratic formula, I'm telling you now, I'm giving you ahead of time, some time to figure it out, this will be a bonus question on the test. I'm just telling you now. Okay? You just have to use this process. I'm telling you what it is. This is it. This process to derive the quadratic formula. You'll know that you got it right because you'll have the quadratic formula when you're done. You'll get x equals the quadratic formula. Like, you'll have that. You'll have solved it. Okay. All right, let's do another one. Okay, how should we start this one? Divide by 4. Oh my gosh, we have a fraction. It's okay. It's okay. We're going to be fine. 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 You guys, we're going to be fine. We have our calculators. There's no need to fear. There's no need to fear. Okay, so we have x squared minus 2x, and then what should I do? Leave my little space, equals, I'm not scared, it's a fraction, fractions are fine. Okay, we're fine, we're fine, we're fine. We can do this. Whew, we can do this. Ooh, we can do this. Don't look at the next one, don't be scared. Don't look at the next one. Okay, we're fine, we're fine, we're fine. We're fine, we're fine, we're fine. Okay, 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 okay. All right. -2, okay. All right, what do I put here and here? -1. Okay? And then what's the perfect square that goes here? 1. Okay. So I'm going to put what in the blank? 1. And now my equation is lopsided. Okay. Okay, so that one's good. All right, so if we write this in factored form, what do we have? Ooh, you went right there. Okay, x minus 1 squared. What's -3/4 plus 1? 1/4. Okay, 1/4. That's not too scary. 1/4. Okay. Add, subtract. Nope. Multiply or divide. Nope. Okay. So we get x minus 1 equals plus or minus 1/2. Oh, that worked out nicely. That wasn't something to be too scared of. Fourth step, we bust inside those parentheses and go back to the beginning. So we have a positive 1/2 plus 1. 3/2, good. So 1.5 is how I'm not trying to trigger anyone. 1.5 is how a middle schooler would say it. 3/2 is how a high schooler would say it. I'm not trying to trigger anyone. I'm just telling you. I'm telling you because I care. You could say 1.5. You could say 1.5. Mixed fractions, 1.5 is just revealing I just got out of middle school. 3/2, the whole improper fraction, that is very high school of us. Because it's improper, and high schoolers are very comfortable with improper fractions. High schoolers love improper fractions. Mathematicians love improper fractions. We are about it. All right, -1/2 plus 1. -1/2 plus 1. 1/2. Positive 1/2. Okay, are we ready for 1 like 6, or should we try something else first? We're ready for 6? We're ready. We can do it. We're fine. Okay. YOLO. This is a YOLO moment. Okay. We're not feeling like this is a YOLO moment? It is. It is not. It is. It is not. You're a little bit confused. Okay. Uh-huh. -1. -1 plus -1. So -1 plus -1 is -2. -1 times -1 is +1. So when you multiply them together, you get +1. But when you add them together, you get -2.
What's -1 plus -1?
They multiply to the top. -1 times -1 is +1, but they add to the bottom. They multiply to the top, but they add to the bottom. They multiply to the top, but they add to the bottom. Jack, did I get you back? Okay. All right. Let's do number 6. Okay, what's the first step? I got that 8. I don't need the 8 there. What do I do? Subtract the 8. Okay. Okay. And then I don't like the 3 either.
I hate 3. I think it's 5/3. It's 10/3. 5/3.
Okay, people who said 5/3, how did you do it? You took the 10/3 and you did what? Divided it in half. Divided by 2. Okay. So if you take on your calculator, if you say, okay, let me do 10/3, and maybe it will feel better if we put this in parentheses. If you take 10/3 and you divide it by 2, and then your calculator says, bleh, decimals, then you say, it's okay, calculator, I can handle this. You hit the math button, and the first option says frac, which is short for fractions, and 5/3. Okay, so we handled that. 5/3. Okay.
25/9. And that's our mystery number.
Okay.
Not right.
Okay. So we are surviving. We are surviving. 5/3, 5/3. We are surviving. Okay, I'm gonna pause this while you work on it. I'm gonna double check and see if I can get that punchline book back. Okay, so what number are we putting on top? I'm switching to purple because I just lost my blue marker. 25/9. That's very strange. Okay. So for those of us who maybe didn't get that number, how did we get 25/9? 5/3 times 5/3 is 25/9. Okay, so 25/9 is the perfect square that goes right here. And to keep it balanced on each side, what do we have to do? Okay, plus 25/9. Okay. So now, when we write our parentheses, what's going to be in our parentheses? Yeah, x plus 5/3. X plus 5/3. Oh, okay. X plus 5/3 squared equals. It's not that I don't trust you. I'm just going to type it on my calculator. How dare you? 0.1111. I'm going to turn that into a fraction. That is, in fact, 1/9. Beautiful, beautiful. Equals 1/9. What? Without question, this is definitely the most difficult problem on the page, without question. So oh yes, we are rocking this one. Okay, now what do we do? Okay. So x plus 5/3 is not 1/3. Don't kill that horsey. Ooh, plus or minus. Oh, thank goodness. Oh, thank goodness. Oh, thank goodness. Okay, I thought you were holding a gun to the horsey's head, but you were not. Whew. 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 Okay, okay. So now what do we do? Now what do we do? Okay, so we get two answers. Positive 1/3 minus 5/3. Negative 4/3. Okay, negative 1/3 minus 5/3. Negative 2. Because it was negative 6/3 and negative 6/3 is negative 2. You guys, we just kicked that problem's tushy. Okay, do we feel like we need to do any more problems on the page? We have aced it. Okay. Okay, so I'm going to show you the answers on the punchline. This is what they look like. I'm interested because some of them have divide by 2, and I'm like, what, why? But why? For why? Yeah. But the thing is, they don't have coefficients at the beginning, so I'm like, why? Huh? Strange. I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perchance. Okay. So, yeah. So we do have a completing the square one in here. Would you guys like to do that one? Because I've got that. So I have that assignment that has a punchline, and then I've got this one, which is, Gina Wilson and perhaps triggering. So what would you guys like to do? You want the punchline? You want the punchline, not Gina. Okay, now the problem is the punchline has no coefficients, Gina does. So I think what I'm going to do is a mixture of both. I'm sorry. Gina's problems look just a little bit more difficult, which we need. So, yeah, we're going to do a mixture of both.